Hi there. Let's go over topic 4 review questions for electricity. Let's do the definitions first. So energy is basically the ability to do work. And so most devices convert one form of energy to another. Kinetic energy is basically energy of moving parts. So if a machine is moving, it has kinetic energy. A thermocouple is a device that has two wires. They're usually different metals, joined such that voltage is produced between the ends based on the differences in their temperature. A thermoelectric generator is a device that uses thermocouples to generate heat directly into electricity. Piezoelectric effect. This is cool. It's a substance that produces an electrical charge when you push on it or force some sort of mechanical stress on it. For example, barbecue lighters, which we'll look at in a minute. And photovoltaic cells, they contain semiconducting materials like silicon, whereby the electrons are excited in the silicon from light to produce an electrical current or the flow of electrons. Question 2 wants us to look at page 239, and they want us to write down several devices that convert electricity to another form. So any device has an input energy, and then it has an output. And so they want us to think of devices that convert electrical energy into another form. Let's take a flashlight. Flashlights use they use chemical energy from a battery. So it's chemical. And from the chemical, we get electrical energy, and from electrical, so chemical to electrical to light. So that's the energy conversions in a flashlight. Now, light is the intended output, but it also produces a little bit of heat, which means it's not 100% efficient. So the other kind of energy that's produced is heat. Let's take another device. Let's say a toaster, a plug-in toaster. So the input again for the toaster is, this time it's electrical, and the output, of course, is heat. The intended output, because that's what it does, it heats something. And so those are two examples of what they want you to do there. What happens when within a thermocouple, when one junction is heated, and what happens when the positions of the hot and cold junctions are reversed? What are the most common metals used? So here's a thermocouple. Thermocouples are, as it says here, are used in spots where you have to measure high temperatures. So they're used as safety sensors in devices like furnaces, hot water heaters, and electrical ovens. So here's the hot junction, and here's the cold junction. Here's what happens. You get electron flow in this direction through the copper wire and back. And so as long as you have two separate metals here and differences in temperature, you can create a flow of electricity from the hot to the cold junction. And so what happens is the positions of the hot and cold junctions are reversed. The flow of electricity just reverses in the other direction. And copper is one of the common metals used. You should have two different metals to have this work. What are common piezoelectric crystals? And what happens when a piezoelectric crystal is squeezed? So here's a barbecue lighter. Squeezing the handle of the barbecue lighter slams a tiny hammer against a piezoelectric crystal, which forces all the particles to be arranged in a specific direction. And when that happens, electricity is created. Let me show you a quick diagram of a piezoelectric effect. So when the particles of a substance are polarized, that can cause a flow of electrons around and back again. And so that's how we create. So when you polarize something, what other one? Let's look at this one. So quartz is a very common, which is silicon dioxide, a common piezoelectric. Aluminum nitride might work too. Next, it says, I talked about a barbecue lighter. Describe 3 ways in which usable light can be produced from electricity. We talked about that already, so that would mean basically thinking up devices that convert electricity to light. And light bulbs, for example, are one. And so what happens is a light bulb has a tungsten wire, and the tungsten wire slows down the flow of electrons, creating more friction and heat. And inside here is a vacuum. And so the vacuum means that light is given off inside this tube as a result. There are different forms of lights. One of the most efficient is LED lights. And so LED lights, light emitting diodes, they don't use much friction and they're super efficient. So 93% is their efficiency, which means they don't give off much heat at all. Whereas this device is an incandescent bulb, and the incandescent bulb generates so much heat that it's only about 12% efficient. Another kind of light is fluorescent bulbs, so tubes with some sort of halogen in here, a halogen gas, and then we basically ignite the halogen gas, so there are tiny little electrodes which generate a little bit of heat, but not as much as in the filament of this. So these are, I think they're in the 20s, 20-some% efficient, so less heat. Electric eels wants you to look at an electric eel. If we chop the electric eel in a cross section and we look at it head on, here's the spinal cord along the top, and just below it, the fleshy part has muscles, and then the electric organs make up most of the fish's body. And so what happens is it conducts electrical currents and it can zap you. Photovoltaic cells. So here's what happens. So on top of roofs of many houses, you can get photovoltaic cells, and here's what they're doing. Light hits the atom of a substance like silicon, and it excites its electron, and its electron basically jumps up to an excited level, and then it comes down through these contacts. What's the problems, concerns with photovoltaic cells? Well, one is if you don't get a lot of sunshine, then you're not generating very much electricity. And also, they're expensive, and they also look at the size right now that they're at. They take up a lot of space, and you would need way more of them than this one to run your whole house. So we need to make them more efficient so that they would fit on the roof of a house to be able to run power to the whole house. So we need to bring them down in size and still produce the same amount of electricity. So hopefully that helps.